We will go through Chapter 1. Chapter 1 is Introduction to Statistics. Data. The definition of data is that it consists of information coming from observations, counts, measurements or responses. And these are two examples. Now, what is the difference between elements, variables and observations? Elements are the entities on which the data are collected. A variable is a characteristic of interest for the elements. The set of measurements collected for a particular element is known as an observation. Keep a note that you have as many observations as elements. You have one observation per element. So if you have 5 elements, you have 5 observations. While for the data values, you have to multiply the number of elements times the number of variables. For example, if you have 5 elements and 4 variables, you have 20 data values. So don't mix up the data values with observations. Now, let's go to see an example. In this case, we have 5 elements, and these are the companies: Dataram, Energy South, and so on. We have 3 variables: stock exchange, annual sales, and earnings per share. Then we have 5 observations. We have 1 observation per element. So that means for Energy South, the observation is OTC 74 and 1.67. So this is the observation for Energy South. And then you have 15 data values. Why 15? You have 3 variables and you have 5 elements. So 3 times 5, 15 data values. 73.1 is one data value, 74 and so on. Now, statistics is the science of collecting, organizing, analyzing. Analyzing meaning we do the different calculations. We calculate the mean, median, standard deviation and so on. And explaining the data in order to take some decisions. Now, what is the difference between a population and a sample? A population is the collection of all outcomes, responses, measurements or counts. So in other words, everybody, everything is part of the population. While a sample is a subgroup or a subset of the population. Let's go to see this example. For this problem, you look for the sample and you look as well as for the population. So the sample, it is going to be the 1,708 adults in the United States. Now, to figure out the population, simply eliminate the number that you have in every problem. So in this case, the population will be the adults in the United States. So just hide the number and this is going to be your population. And the sample is going to be the number that is given. In this case, 1,708 adults in the United States. So this is going to be the sample. Now, about the dataset, we have 939 yeses and the remaining 769 will be the no's. Now, what is the difference between parameter and statistic? Parameter is a number that describes a population characteristic. So keep in mind, parameter for a population, PP. While a statistic is a number that describes a sample characteristic, SS. Now, what is the key word? In this example, age of all people in the United States, all. So that indicates a population. So this is a parameter. While here it says a sample of 3 states, a sample of 3. So this is going to be a statistic. Let's go to see a couple of examples. Example number 1. A survey of a sample of MBA reported that the average salary is more than 82,000. So in this case, because we have a sample, then we will have a statistic. So we have a sample statistic. The average of 82,000 is based on a subset of the population. Let's go to see the second example. In this case it says starting salaries for the 667 MBA graduates. That means all MBA graduates. As a result, if we have all MBA graduates, then we talk about a population. So if we have a population, then we have a parameter. So population parameter, because it's based on all 667 graduates. Difference between descriptive statistics and inferential statistics. The descriptive statistics involves organizing, summarizing and displaying data. For example, tables, charts, calculations, and what I mean by calculation, standard deviation, average, and so on. While inferential statistics involves using sample data to make conclusions about the population. Let's say, for example, we want to see the GPA of the students in a university. So we choose a class as a sample, and based on this class we can calculate the GPA for the specific class and make conclusions about the whole university. Let's go to see this example. We have a sample of men, 48 years old, that we follow them for 18 years. For unmarried men, 70% were alive at the age of 65. For married men, 90% were alive at the age of 65. So from here, the descriptive statistics will be the actual calculations, the 70% and the 90%. However, the inferential statistics is that married men live longer. So in the first paragraph we have the descriptive statistics, and then we have the inferential statistics on the second paragraph, that based on this study married men is associated with longer life. Now, the types of data could be qualitative or quantitative. The qualitative will be labels, names, or non-numerical entries. However, sometimes they could be numeric, but if we use numeric information, this is going to be codes, so you cannot do any calculations. For example, for major, you may have a nursing, math, business major, or you may have a code, 1 for nursing, 2 for math, 3 for business, and so on. Eye color, blue, brown, and so on. Blue could be 1, brown could be 2, and so on. While quantitative data are going to be always numeric, and then you can do calculations. And these are 3 examples: age, weight of a letter, and temperature. Now, let's go to see these examples, if the data will be qualitative or quantitative. Nationality, for example, American, Indian, and so on. So this is going to be qualitative. Number of children in a family, 1, 3, and so on. So this is a number, this is going to be quantitative. Household income in the previous year, 40,000, 50,000, so this is going to be quantitative. Level of education, master degree, high school diploma, and so on. So this is qualitative. Daily intake of whole grains, 50 grams, 20 grams, so this is going to be quantitative. So these are some examples for qualitative and quantitative data. The next step is to figure out the difference between discrete and continuous variables. Discrete is a quantitative variable that has a finite number of possible values or a countable number of possible values. Discrete is related with how many, something that you are able to count, 0, 1, 2 and so on. While continuous is also quantitative but can take any values in an interval or collection of intervals, could be any number in an interval. Continuous usually is related with how much. So an easy way to figure out if it's a discrete or continuous is how many or how much. Or think, for example, if something can take integer values or can take any values. Integer counting process will be discrete. Let's go to see this example. Number of children, 1, 2, 3 and so on. So you are able to count how many children. So this is going to be discrete. Household income could be any value. So this is going to be continuous. Daily intake of whole grains, how much? So this is going to be also continuous, could be any value in an interval or collection of intervals. Now, the qualitative data may follow the nominal level of measurement or the ordinal level of measurement. The nominal could be names, labels, and the difference between nominal and ordinal is that order is not important. So for example, we have employment classification, ethnicity, gender and so on. Gender could be male, female, ethnicity, African American, Anglo-American, employment classification, educator, construction worker and so on. So order is not important. While for the ordinal scale of measurement, it is similar to the nominal, however order is important. Keywords: rank, order, or rate. When you rate a hotel, a restaurant and so on, this is going to be the ordinal scale of measurement. So we have some examples. Position within an organization, 1 for president, 2 for vice president and so on. Or your status as a student, if you are freshman, sophomore, junior, senior. And again one more time, when you rate a hotel, a restaurant and so on. So this is about the qualitative data of measurement. For quantitative we have the interval and we have the ratio. Now for the interval and the ratio you have to check the 0. A value of 0 in the interval level of measurement does not mean the absence of an event. For example, we may have a 0 degrees for temperature. This is just a number. We can have a negative degree for temperature. So as soon as 0 it is just a number on a scale, this is the interval level of measurement. And these are some examples: Fahrenheit temperature, monetary units and so on. While for the ratio, a value of 0 in the ratio level of measurement means the absence of the quantity. You cannot have negative numbers, and 0 means absence of the event. Some examples: height, you cannot have a negative number; weight, the same thing; salary, age and so on. Let's go to see an example. The first step that you have to do is to figure out if the data are qualitative or quantitative, and then to figure out the scale of measurement. So number of snack and soft drink vending machines in the school, 5, 10 and so on. So this is going to be numeric, that you can do a calculation, so it's quantitative. If it's quantitative, you have to figure out if it's interval or ratio. In this case, because you cannot have a negative number and 0 means absence of the event, this is going to be the ratio scale of measurement. B, whether or not the school has a closed campus policy during lunch, yes or no. So this is qualitative. Yes or no is just a response. Order is not important. So between the nominal and the ordinal scale of measurement, this is nominal. Class rank, freshman, sophomore, and so on. This is qualitative, however order is important, so we follow the ordinal scale of measurement. Number of days per week a student eats school lunch, 2 days, 3 days, so this is quantitative. You cannot have a negative number, so this is going to be the ratio scale of measurement. And these are the PowerPoint slides for chapter 1.